Hello, this Mathmotor video is going to be going over how to find the volume of a cylinder. And we use this handy formula here that states that the volume of a cylinder is equal to pi times the radius squared times height, or also commonly used is volume is equal to base times height. So let's get a better understanding of all these variables used, and then we'll go ahead and work out this example over here. So V is equal to volume, and volume is that three-dimensional measurement we're looking for here. We're asking how much can we fill into this cylinder here. Okay, if this were a trash can or a barrel, volume asks how much can we fill this shape with. And we measure volume with these cubic units here. Okay, so then we have R for radius, and here it is right here. If you notice that the top and the bottom of a cylinder are in the shape of a circle. So the radius is going to help us find volume. And here you can see that the radius extends from the center point of a circle out and touches the circumference. And then H is equal to height, and as you can see here, represented by this arrow here, and our height in this example is equal to 6 centimeters. Next we have pi. This symbol here is equal to pi, and we use an approximation of pi that is equal to 3.14. Okay? And pi is a unique ratio that we use with circles, with finding measurements of circles and shapes such as the cylinder that have circles for its bases. Okay, and then this capital B is equal to pi r squared. And if you notice, that's the exact same for the formula of finding the area of a circle. So really, you just need to remember that this capital B stands for base, okay? And it's unique to each shape. So the base of a cylinder is a circle, as you can see here. So just remember, when you see this big B, you need to ask yourself, what is the shape of the base? And then you apply the area formula for that shape. In this case, it's a circle. So it's pi r squared. Okay, let's get started on this example here. So I went ahead and I plugged in the known values here. We know that pi is approximately 3 14/100ths. Then we have our radius of 2 centimeters. So we're going to put in here our 2. And we need to put our exponent of 2 here because it's going to be squared. And then our height is 6 centimeters, so that's going to be represented here. So our H is 6. Okay. So I went ahead and I expanded out this exponent form here because it does represent 2 times 2. So now you can see that this is just a straight multiplication problem here to solve for volume. Okay. And it's always a good idea to start from the back end here and work your way towards pi. This way you just have these whole numbers here that are easier to multiply together, and then you'll only have one decimal number at the end of your problem. Okay, so 2 times 6 is equal to 12, and I always have my students rewrite their work in a flowing, organized, and neat manner like this here, so you don't skip a step or you don't repeat a step. Okay, so we solved for 2 times 6. We bring it down here and we rewrite everything else that hasn't been worked out yet. Now we're going to do 2 times 12. That gives us 24, leaving us with pi times 24. And there's our answer. The volume is approximately 75 36 centimeters cubed. And so you're probably asking yourself again, what is this squiggly equal sign here? Well, this is an approximate equal sign, and we have to use this anytime we're working with pi because 3.14 is a rounded decimal approximation of pi. Pi is actually an irrational number, and it just doesn't stop. If you use the other rational form of pi, 22/7, you can punch 22 into your calculator, divide by 7, and you will see that pi just never stops. It fills up your whole calculator screen and it just keeps on going. So we have to use an approximation, and for school and academic purposes we use 3.14, which gets us very close, and we can use it to apply to these problems here, solving for measurement. Now you're probably also asking about this third power, or what we call cubed. Remember from prior learning, you probably learned squared from area, which is a two-dimensional space. Like if we look at the base of this cylinder here, this is squares, they're flat. Okay, it's just length times width. When we're talking about volume, we have length times width times height, that third dimension. It creates these cubes here that we're all fond of drawing. So that's what that is for here, cubed. We're talking about cubic centimeters. Okay? And so we can fill this cylinder here with 75 cubic centimeters and then also 36 hundredths of a cubic centimeter. And I just drew this smaller one here to represent that. It's really like taking a cubic centimeter and cutting it into 100 equal parts and taking 36, and you would get something like this. Again, this is not to scale. It's going to be different sizes depending on what kind of monitor you're watching this on, but just to give you an idea of volume. Okay, so I wanted to show you the relationship between area and volume. As you can see, the formula for area of a circle is pi r squared, and if you notice, that's the majority of this volume formula. The only extra thing we have is that third dimension of height. Okay, so you can see here I went ahead and worked out the area of the base. This is as if we were looking at this cylinder over here from the top or from underneath from the bottom. So we have a area, squared area of 12 and 5600 centimeters squared. And if you notice, it looks the same here. The perspective is slanted here because this is for our 3D cylinder here. Okay, so then all we do is we just add height, and that takes these squares and turns them into cubes, and we have these cubic measurements here. 75.36 centimeters cubed inside, and that'll wrap up this video.